Welcome. Since we are finished with alkane, alkene, and alkyne nomenclature, I figured this would be the appropriate time to bring on these two subtopics. One is a Zaitsev rule, and the other is cis-trans isomers, because I think they fit better here than anywhere else. Um, why do we need to know this? Because once we actually start to learn reactions, then we talk about major product and minor product. Okay, one way of determining which product would be major, say if the product contains a double bond, is to use the Zaitsev rule. Okay, now what is the Zaitsev rule? Okay, I've shown the definition in red. This is the proper definition or technical definition as it will be available in a given textbook. While not always, it's very important, more alkylated alkene is more stable. Now, if you literally read that definition, you can keep reading it 1,000 times. Unless you really know what alkylated alkene means, you would never understand the definition. So, is there an alternative way of interpreting this definition? Yes. And that would be the more centered the double bond is in a molecule, the more stable it'll be. Does that make sense? Compared to this technical definition you see, there's an alternate way of defining the same exact definition, and that would be the more centered the double bond is, the more stable it will be. And that's all there is to it. Like I said, you need to know this concept because, again, once we start learning actual reactions and making products, if a compound contains a double bond and it happens to be an alkene derivative, then you need to know which one will be a major product and which one will be a minor product. So more stable means more stable will be the major product, less stable would be the minor product, and that's obvious. So let's wrap this video up with a couple of examples because it's a fairly simple concept. But usually the problem is people have trouble recognizing and understanding the definition as it's written on the screen. So the modified definition would be more centered, okay, the double bond, more stable. Okay, that's all. That's kind of an alternate way of defining without actually changing the meaning. So I have 4 compounds here. I think they're all derivative of each other. In other words, they're isomers. All I have basically done is move the double bond one place across. Now, let's say one being the most stable and 4, because we have 4 compounds, 4 being the least stable, okay, and anything in between. Let's start assigning numbers. As I said, more centered the double bond in the molecule, more stable it is. Visually, which one do you think is more centered? Would you say this or this? I would say this. I still think this is more centered in the molecule. So this would be 1, more stable. This would be second because I still think if you're in doubt, just count. I mean, on this side of this double bond, there's 1, 2, 3 carbons, right? On this side of the double bond, there's only 2. So compared to this is a little bit more centered. Would you agree? Let me repeat. You have to pick the double bond. That's what we're focusing all this around, okay? You pick this double bond, there's 1, 2, 3. You have to do it for one side. That's enough. You don't need to do it for both sides. So on this side, we have 3 dots, right? On this side, we have 2. If one side is less, the other side is going to be more. But again, what we're really trying to say is definitely this is less centered compared to this, right? So this would be number 2. Obviously, this is number 4. Clearly, it's at the very end, and this is 3. Okay, so stability is 1, 2, 3, 4. So more centered, the double bond, more stable. Now, yeah, 2 and 3 is a little tricky, but again, you can tell this is a little bit more inside the chain. This is a little bit outside of the chain. So what I mean by outside is this is not actually, kind of more towards getting towards the end of the long chain sequence. This is kind of more inner. So that's how I decided to go with 2. But then I also showed you mathematically how one is stronger than the other. And that's Zaitsev rule. So one would be if this were a reaction and these 4 products were formed, the major product would be 1 and 4 would be minor product. Again, we're not doing any reactions, but I'm just saying if we had done a reaction and these are our 4 products, this is what we expect to be your major product. That's what you expect to be your product. And that's all there is to Zaitsev's rule. All right, so stay tuned for cis-trans isomers video.